Hey everyone, today we're going to talk about real, imaginary, and complex numbers. So far everything you've ever dealt with is a real number. These numbers are called real because they represent easy to draw concepts. Somebody's going to say, how do you draw pi? Well, pi is the circumference of a circle with a radius of 1. No, I'm sorry, with a diameter of 1. However, not all numbers are real. Not all numbers can be easily drawn. Imaginary numbers are numbers that do not represent a simple quantity. They are created by taking the square root of a negative number. This is important. Taking the square root of a negative number. Imaginary numbers denoted I, and I means the square root of negative 1. Well, let's talk about powers of I. I to the first is just I, just like x to the first is x. What about I squared? That's the square root of negative 1 squared. That's negative 1. I to the third is I to the first and I to the second. So if I multiply those two things together, I'd have negative I. I to the fourth is this squared. So it's negative 1 squared. It's positive 1. Now the interesting thing about I is it repeats itself. And you can go through and prove this yourself. We'll talk about it a lot in class. But I'm just telling you right now, quickly, for the short notes. So, they repeat themselves. What if I want to simplify I to a large power? I divide 4 into n. I use the remainder as the new power, and then I simplify. So, for example, I to the 63rd. So, 4 will go into 63. 4 will go into 6 one time. That's 4, 2, 3. 4 will go into 23 5 times with a remainder of 3. So I to the 63 is the same thing as I to the third. And what did we just say I to the third was? It's negative I. At the end of these problems, you should never, ever leave an I with a power in it. Complex numbers have a real and an imaginary component. 2 minus 5i is a complex number. 2 is the real part, minus 5i is the imaginary part. How do we add or subtract these things? We just add or subtract the real and the imaginary parts separately. So, let's add the real parts. 4 plus negative 5 is negative 1. 3i plus negative 3i is 0i. So there you go. You don't need the 0i. I just put it on there to show you that it is a complex number. It just doesn't have any i's. How do I multiply complex numbers? I distribute. I change I squared to negative 1. And I combine like terms. So let's distribute. I get 8 minus 10i plus 12i minus 15i squared. So let's combine what we can combine. Negative 10 plus 12 is 2i. This is going to become negative 1. Negative 15 and negative 1 is plus 15. But 8 plus 15 is 23 plus 2i. Just distribute it out, combine your like terms. Let's try this one. That's going to be negative 18 plus 18i minus 3i plus 3i squared. This is going to become minus 3 because I squared is negative 1. This is going to become 15i. Now put the last number and the first number together, I get negative 21 plus 15i. Multiplying again, not too bad. Dividing is not fun. Determine the conjugate of the bottom. Same number but opposite operation. Multiply the top and the bottom by the conjugate. Turn I squared into negative 1. combine and simplify. So let's figure this out. We need to multiply the top and the bottom by the conjugate of the bottom. The bottom is 4 minus 3i, so the conjugate is 4 plus 3i. If I do it on the bottom, I have to do it on top. So, it helps if you put them in parentheses, so let's multiply everything out on top and everything out on bottom. On top, you get 8 plus 6i plus 12i plus 9i squared. On bottom, you get 16 plus 12i minus 12i minus 9i squared. Now let's clean this up a little bit. Let's see what will cancel. Those two can go together and become 18i. That can become negative 9. So on top, I've got 8 minus 9, which is negative 1 plus 18i. On bottom, these two will cancel out because they're positive and negative. This is going to become plus 9. 9 plus 16 is 25. Let's make it harder. Let's take a look at this problem. The conjugate is the bottom with the opposite sign. If I do it on bottom, I have to do it on top. Parentheses help to see that you're multiplying. You don't have to put parentheses, but they help. On top, I get 20 minus 8i square root of 3 minus 5i square root of 3 plus 2i squared square root of 9. On bottom, I get 25 minus 10i square roots of 3 plus 10i square roots of 3 minus 4i squared square root of 9. Now let's do some cleanup. Minus 8i square root of 3 minus 5i square root of 3, that's negative 13i square roots of 3. This is going to make it negative. This is going to become 3. 2 times 3 makes negative 6. So on top I have 20 minus 6, which is 14 minus 13i square root of 3. On bottom, these middle two will cancel out. That's what conjugates do. This I squared is going to make that a positive. That's going to become a 3. And 3 times 4 is 12. 12 times 25 is 37. So those are complex numbers. Add, subtract, multiply, and then divide by multiplying by the conjugate. If you have any questions, guys, come see me. Thanks.